Hello y'all, we are Memphis Communiversity and today we are doing another Calculus Done Wrong lesson where we wrong calculus before calculus wrongs us. And today what we're going to be doing is we are going to be reviewing limits. So we're actually not going to learn anything new. We're just going to review our past 3 previous videos. Those videos were limits involving infinity. Those was same heavy, top heavy, bottom heavy. The second video was limits as definition of the derivative, the h way and the not h way. And then finally, the third one was the universal process of L'Hopital's rule. So what we're going to do in this video is we're going to practice examples from each of those 3 types of videos because in my opinion, limits are harder than derivatives. When you're doing derivatives, it's really the same thing over and over and over again. But when you're doing limits, you often want to choose the best way to optimally do that limit. And as you might know from our past 3 videos, those methods are quite different from each other. Some involve derivatives, some involve reworking the question, as we're going to see. So today what I'm going to do is I'm going to briefly introduce and go over and recap, maybe provide a few reminders of each of the 3 ways. And then what we're going to do is we are going to practice some examples because that's the best way to practice math, just doing examples. Before we start, if you haven't seen our previous 3 videos, I highly recommend watching them because we go in depth into each of the methods. But let's try to review these 3 things. So again, the majority of limits on college calculus exams and the AP exam can be done with these 3 methods. So limit review. So the first one is limits involving infinity. So limits involving infinity, usually when x is approaching infinity, or negative infinity. So when we do that, when do we do this method? It's when you have limits as x going to infinity and negative infinity, as the name implies, and you usually have a polynomial divided by a polynomial. So it's going to be limit as x goes to positive or negative infinity, and then you have a polynomial divided by a polynomial. So we write poly divided by poly. And remember that there's 3 different things. What you do is you look at the leading exponent of both the numerator and the denominator, and you compare them. If the bottom one is bigger, then it's called bottom heavy. We'll just write bottom h because I'm running out of room. But bottom heavy, and that answer is always 0. That's pretty nice. Then you can have same heavy questions. That's when I don't know how to write the letter h. Got confused there for a second. But that's when the leading exponents are the same. So like you have a quadratic over a quadratic or a cubic over a cubic, something like that. For those answers, you look at the ratio of the leading coefficients of the numerator and the denominator. So this is a ratio. And then finally, in my opinion, the top heavy is the hardest one. That's when the numerator's exponent is bigger than the bottom's exponent. So this is top heavy. For example, you have a cubic function over a quadratic function. And why is it a little bit harder? You have to be careful with infinities. The answer is either positive or negative infinity. You also have to be careful about negatives when you're doing the square root sin heavy questions, which we hopefully will talk about, or at least provide one example of in this video. So number 2, that's the first method. The number 2 is limits as derivatives. Again, derivatives in my opinion are a little bit easier. So for that method, what we're doing is we're recognizing that certain limits are derivatives, and then we just change the limit question into a derivative question, which is just a nice little story there. So this is limits as derivatives. We might just derive. Remember that there's 2 different forms that these limits take based off the definition derivative. So it's limit as x goes to a, f of x minus f of a, just slope, where x is approaching a. And then the second one is the one I call the h method. It's going to be limit as h goes to 0, f of a plus h minus f of a over h, which is again slope. So once you recognize these 2 things, remember what you do is you identify a function, you take the derivative of the function, because we turned that awful limit question into a nice derivative question, and then we plug into a. So find f of x, find a, and then find the derivative and plug in a for this question. Because we're changing the limit, we're recognizing that the limit is a derivative, and we're using this method. Keep in mind though that you only can do this method number 2 when this limit and when the limit is of this form. So like h is on the bottom, h goes to 0, whatever, x minus a, x going to a, things like that. The third way, which is my favorite way, is to L'Hopital's rule. So fun, so fun. So the hospital, whatever you want to call it, L'Hopital's rule. So for that one, what you do is you verify that the limit of your fraction is 0 over 0 or infinity in an indeterminate form. And then what you do again is you do derivatives. So you take the derivative of the numerator, the derivative of the denominator, and you just do it again. So it's going to be the limit as x goes to a of f of x over g of x. If this is equal to 0 over 0, what you do is you take the derivative of the numerator, derivative of the denominator. So let me quickly write this so I can get out of the way. So this is L'Hopital's rule. This is my favorite way to do limits. You can actually do every single limit of form 2 by form 3, method 3. You can L'Hopital for any limit as definition or derivative, but we're going to practice definition and derivative because a lot of students prefer that one. But just keep in mind that we are going to be taking derivatives in step 2 and in step 3. Anytime you're taking derivative, you have to follow derivative rules, especially the chain rule. So that's the rule. Little chain rules, just little 2x's or negative x's sprinkled throughout the questions. That's where my students mess up, so just be careful about that. But pause the video if you need to record or write down these 3 methods, because now is the exciting part. Now we get to practice examples. So let's do that. So again, let's just try to do as many questions as possible throughout this video. What we're going to see limits on each of the 3 types. So I'm going to erase this now. Let's erase. How exciting. Great way to start off the week if that's when you're watching it. Let's erase this so we have enough space. So I'm going to write 3 limits on the board. I'll let you pause the video and try them yourself, and then we'll practice together. Because friendship is good, I don't know. So limit as x goes to negative infinity, 3x squared plus 2x plus 1, 4x cubed minus 6x plus 2. So this is my first one. Be sure to check that one out. Then I'm going to write another one, because we might as well bombard ourselves with limits. So fun. Don't know what I'm saying anymore. Let's do something fairly simple. Let's do x to the 4th minus, what's 2 to the 4th? I believe that's 16. So we're just starting off at a fairly basic level, and then we'll do some harder ones later. And then let's do 0 is always a nice number. And then I believe this should work. Let's change this to a 3. Okay, so try to do these 3 limits. They're not too bad. We're starting off at a basic level. Pause the video, take a little bit of time, and let's do these together. So I'm going to count down from 3, 2, 1, and then we will be ready to go. 3, 2, 1, let's go. So the first one I'm looking at infinity and negative infinity. I see a polynomial over a polynomial, so I believe that this is going to be a limit involving infinity. So remember, what you do is you look at the leading exponent. In this case, the leading exponent of the numerator is a 2. The leading exponent of the denominator is a 3. So then we have to determine if it's same heavy, top heavy, bottom heavy. Remember that you're always ignoring all of this stuff. So now what we need to do is we need to compare 2 and 3. Last time I checked, 2 is smaller than 3, so it looks like we have something bottom heavy. 2 is smaller than 3, so you have something bottom heavy. And bottom heavy are the easiest questions in the world, because anything that's bottom heavy, sorry, I didn't have a V here. Don't know how to spell the word heavy, but anything that's bottom heavy is 0. So that question's pretty easy. So we're good to go, Just keep in mind, if this was a squared, so it'd be 4x squared, then it'd become same heavy, the answer would be 3/4, because in same heavy, you do the ratio of the leading coefficients. So that's that. So this question looks like a limit of definition of derivative, because we have f of x minus f of a over x minus a going to 2. So remember that when we're doing definition of derivative, so we can write definition of derivative. What you want to do is you want to identify a function, then you want to take the derivative after identifying a number as well. So what's the function? Remember that when it's in the not h form, which is this form right here, it's very easy to identify the function. It's just right here. It's just staring at us. It's x to the 4th. So it's x to the 4th. What's the a? A is even easier because it's in 2 spots. It's right here, 2, and it's right here, 2. So that's that. A is equal to 2. And then finally, what you do is once you identify these two things, you just take the derivative and plug in this number. Keep in mind that we don't use this number 16, but you can check if you're doing the work correctly by plugging this a into our function. So when you plug in 2 to the 4th is 16. 2 times 2 times 2 times 2. So now we don't have to look at the limit. We did our goal. Good job, us. We changed this limit into a derivative question. So we're just going to take the derivative. So f prime of 2, we just take the derivative. So it's 4x cubed. We can use vertical bar notation. So this just means I'm going to plug in 2. So it's going to be 4 times 2 cubed. 4 times 2 cubed, I don't know what that is. I believe that's 2 to the 5th, so that's going to be 32 actually. So just be careful with your actual numbers, but we should be good to go. So again, definition of derivative, pretty classic example. Nothing too much to say about this. Have the function, have the a, take the derivative, plug in the a. So this question right here, you cannot do definition of derivative because notice the denominator is so complex, the e to the x is complex. This one looks like it's L'Hopital's. So what you do to start off with a L'Hopital's question is you need to plug in 0 and verify you get an indeterminate. So that is a step that some students skip, but there's a few questions. If your teacher's really tricky, like I am, there will be maybe 1 or 2 questions where you just get a number and you're done. So that's actually plug in 0. When you plug in 0, e to the 0 is 1. 1 minus 1 is 0, so we get 0 on the top. Then when you plug in 0 here, you'll notice you'll get 0 plus 0, that's going to be 0. Looks like we are ready to look that tall. It is time for L'Hopital's rule. So for L'Hopital's rule, what we do is we take the derivative of the top, derivative of the bottom. Please do not confuse this with quotient rule. Quotient rule is to take derivatives of quotients, but here we're doing a limit which happens to take derivatives, if that makes sense. So all we're going to do is take the derivative of the numerator and the derivative of the denominator. So let's do that real quick. So let's make a little barrier from the previous question. It's going to be a limit as x goes to 0. The derivative of e to the x minus 1 is just e to the x, because the derivative of minus 1 is 0. Then this derivative is pretty easy as well. It's 2x plus 3. And then all we do is we plug in 0 again. When you plug in 0, it'll be e to the 0, which is 1. 0 plus 3, 3. It looks like we have our answer 1/3. Keep in mind, of course, that sometimes you have to apply L'Hopital's rule multiple times. If you got 0 over 0 again, that's okay. But what I would recommend, if you do get 0 over 0, if you're applying multiple L'Hopital's rules, doing it back to back, what you should do is you should simplify whatever you have here and then take derivatives. Because usually that'll cancel out some stuff. But these are our 3 basic examples of a definition of derivative, and a L'Hopital's rule. And because we're having so much fun, why don't we do some more? So I'm going to erase this now. Erase, 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 erase. Erase. So let's see. What do I want? What do I want? So let's do a limit. All these questions, of course, have limits. But limit as x goes to pi over 6. Let's do some trig, because trig is super annoying. Let's do h plus pi over 6. I can't read my own handwriting. Pi over 6. I believe that we want root 3 over 2. My trig is correct. Cosine of pi over 6, I believe, is root 3 over 2. Is that correct? I think so. And then we have 8. So this is going to be my first question. Again, I'm going to try to do 3 questions in one. So we're going to have limit as x goes to negative infinity, and we'll have this guy right here, square root of 49x squared. As you can maybe tell, I did not prepare it all, so apologize, but sometimes it's nicer to do things sort of in the heat of the moment. So on the bottom here, I'm going to have 8x. Let's have 8 minus 9x. Then, what should we do for this last one? Limit as x goes to, what should we do? So many choices, so many choices. Let's do a lot of stuff with trig. So cosine pi x. Hopefully you're just working on the ones above it as I start making up these questions. But here, I think we want this. And then on the bottom here, let's have this. No, that doesn't make sense. Let's just do something simple. So this is going to be my question. I think we're good to go. Yeah, so again, pause the video if you want to try these 3 questions, and then we'll come back in 3 seconds to see what we got. Let's see what we're made of. So 3, 2, 1, let's get going. So the first one is pretty obvious that it's a definition of derivative question because it involves an h. So same thing as the other definition of derivative question, the same method. What you want to do is identify a function, identify a, take the derivative of the function, plug in that a. So we're going to do that. When I do the h ones, I like to identify the a first instead of the function. The a is always the thing getting added to h, so notice that it's pi over 6. So what's the function here? Well, the function, what some people like to do is they, in the general form, it's the f of a plus h. So they look at the a they just found, they add it to h, and they look at what function is that thing getting plugged into. So it looks like that thing is getting plugged into cosine. If you want, you can cover it with an x. So this is going to be cosine x. We can check our work. Hopefully my trig is good, even though I teach trig, I suck at it. When you plug in pi over 6, cosine of pi over 6, I believe is root 3 over 2, because it's the longer side. So it looks like we have the right thing. We have done our goal. We have changed our limit question into a derivative question. All we have to do is take the derivative and then just finish the answer. So what it's going to be is f prime of x. That's negative sine of x. Be careful with that because the derivative of cosine is negative sine of x. So negative sine of x. Then we are going to plug in pi over 6. So it's f prime of pi over 6. That's going to be negative sine of pi over 6. And if you know your unit circle, sine of pi over 6 is 1/2. So it's going to be negative 1/2 is the answer. We'll sort of box it out so that we're not sort of blocking this question. So that's another pretty easy definition of derivative question. Identify the function, identify a point, take the derivative, plug in that point. So this question right here, I'm going to argue that this is same heavy. This is the square root same heavy question. So just like with the top heavy questions, what you want to do is you want to be careful with negatives throughout this question. So if you look at this, this is same heavy. So what we can do is we can ignore anything that's not the leading term here. So notice that I can get rid of this -1 because that's not the biggest guy. On the bottom, the 9x dominates the 8, so I can get rid of this 8. So what is this basically like? Well, on the bottom, it's definitely like negative 9x. So we'll change this equal to approximate. And then the top, while it's not the exact same thing, because we might be losing a negative, it's really similar to 7x. The square root of 49 is 7. The square root of x squared is x. So this is going to be like 7x. So there's one correct answer. There's one best wrong answer. So if you wanted to, or if you wrote 7 over negative 9, I believe that's the best wrong answer. And let's see why that's true. Because, again, you have to be careful with negatives. And when you're being careful with negatives, what you're trying to do is you're trying to plug in negative infinity, in this case, because we're going to negative infinity, into the original numerator, into the original denominator, really the leading powers of the numerator and the denominator, and just see if that thing, if that quantity is negative or positive. So, for example, when you plug it into this, 8 is so small compared to this that we're really only plugging into this. Negative 9 times negative infinity is going to be a positive number. So this is going to be positive. So when we plug in negative infinity into the original's denominator, this quantity is positive. When you plug it into the numerator, the square root squaring is doing weird things with the negative because it's getting rid of the negative. If you take the number negative 8, you square it, you'll get 64. Or take the square root, you'll get back 8, and you won't get back the original thing. Same thing here. When we plug in negative infinity, the negative goes away. When you square it, you square root it. So on this time, you also have a positive number. So what should we expect our answer to be? Well, we have a positive number over a positive number. That means that our answer should not be negative 7/9. It should just be 7/9. And that's that. So again, anytime you have a same heavy square root question, a similar thing is with top heavy questions, you do want to be careful with these negatives. So my last question, not too crazy. you can recognize that it's probably going to be L'Hopital's rule because it's not of the definition derivative form. Remember, you can't apply same heavy top, heavy bottom, heavy, certainly not even by looking at this, but you have to be going to infinity or negative infinity to apply those heaviness rules. So for this, we are just going to probably do L'Hopital's rule. So what we want to do is we want to verify that we have an indeterminate form, 0 over 0. So let's do that. When we plug in 1, cosine of pi, -1 plus 1 is 0. Then when you plug in 1, you'll get 1 squared. 1 minus 1 is also 0. Now it's time to lope that tall. So when we're loping that tall, take the derivative of the top, derivative of the bottom. So the derivative of the bottom is pretty easy, so I'm going to do that first to build my confidence. The derivative of x squared minus 1, I believe, is 2x. Then the derivative of the top is pretty easy as well, plus 1, that's fine. The derivative of cosine is minus sine pi x. But just be careful, please, 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 please be careful. Anytime you're taking derivatives, you have to do the chain rule potentially. My students know to do that when they're just straight up derivative questions. But when derivatives are involved in a question, like this L'Hopital's rule, that's when they forget it, and it's so sad. So the derivative of cosine pi x is not just negative sine pi x. You have to multiply by the derivative of the inside function, that's times pi. So you just have to have this times pi here. Actually, in this question, it doesn't matter, as you'll see, but just really know those chain rules. Those are the things that my students miss the most. And maybe it's because I don't teach them well, maybe not. So what happens at this stage, what you want to do is you just want to plug in 1 and finish the game. So when you plug in 1, you're going to get sine of pi on the top. Again, this is why it doesn't matter, because when you're dealing with the angle pi, you're having the point on the unit circle -1 comma 0. So cosine of pi x was -1, sine of pi x, sine of pi, that's the point -1 comma 0. So you choose the y coordinate, that's going to be just 0. So the numerator is just 0. The denominator is 2. When you plug in 1 times 2. So 0 over 2 is just 0. So this is the answer. Not too exciting, but still a nice demonstration that you still need to be careful with chain rule. You can expect questions to involve chain rule because chain rule is more fun than non-involving chain rule, at least in my opinion. So those are our middle level questions. Let's do 3 more. Let's do another round of 3. Now we are getting into the fun stuff. Buckle your seatbelts. I don't know. Let's just keep going. Let's just erase the board here. Erase, erase, erase. Erase, erase, erase. So the next 3 questions, hopefully we'll have some harder questions. Let's start off with this guy right here. Just making some stuff off the top of my head as normal. So this is the first limit I want. The second one I want is this guy. Now let's change this. Let's change this to a nice e to the x. Minus 2, 1, plus 8 e to the x. So this is my next question. And then finally, my last question, let's just be super crazy. Let's go to 0. And I believe I want this guy, this guy. Let's involve trig, because trig is our friends. It isn't, but whatever. So these are my next 3 questions. If you want, you can pause the video, of course. Challenge yourself, try these 3 questions. If you can master these questions, I'm very confident that you can do well on limits. And if you can't, that's what we're here for. That's what we're here having fun. So 3, 2, 1, let's get going. So this first question is technically L'Hopitalable, if that's an adjective, but I'm going to do the normal apply the definition of the derivative. So we are of the form x minus a, x is going to the number, so I can just apply our definition of derivative. What's the function here? Well, the function is just looking at us right here. Even if we try to avoid its gaze, it's still looking at us, so it's going to be ln x. So just ln x. The a is very easy, it's just one of these 2 numbers, 3 and 3. We can check ourselves if we're being careful. If we plug in this number, we should get this top right number. Looks like we do, so we're good to go. Then we need to actually do the method, but we are done with the hard part. No more limits, now just a derivative. Pretty easy derivative, just take the derivative of this, plug in the number. What's the derivative of ln of x? That's of course 1 over x. So our final answer looks like it's going to be 1/3. Just cautionary tale, sometimes people like to lope that tall for everything, apply L'Hopital's rule for everything, and that's perfectly fine. You could apply L'Hopital's rule here, because you would get 0 over 0 when you plug in 3, but just be careful when you take the derivative. So I'm just going to do that verbally here. The derivative of the bottom would be 1, so that's very easy. That's not where people mess up. The derivative of ln x is 1 over x. Again, that's not where people mess up. They mess up at ln of 3 because they know the derivative rules so well that they want to apply them to everything they see, which is noble but somewhat foolish because ln of 3 is a number. It's like 3 itself. It's a number. If you type it in a calculator, you're going to get a number. You have no x's. So what's the derivative of 3? Well, it's 0. What's the derivative of -2? Well, it's 0. What's the derivative of pi? It's 0. What's the derivative of ln of 3? Even if it's a weird number, that derivative is also 0. So if you were to do L'Hopital's rule, your next step should read 1 over x minus 0 over 1. You plug in 3 and you'll get the same answer as 1/3 because math is consistent. It works out if you do it correctly. So if you want to L'Hopital's rule every single question, just be careful with these guys right here. I've seen things like the square root of 12, the derivative of that is 0, and so on. So just be careful with that. So this question, we're going to infinity and negative infinity. It looks like we can apply our heaviness rules, but if you're not incredible at heaviness, and nobody really is, I would not recommend doing our same heavy, top heavy, bottom heavy. I only do those when I have a polynomial over a polynomial. And in this case, I had exponential over exponential. Maybe with the square root ones, I do same heavy, but in this case, you might not know whether this is same heavy, top heavy, or bottom heavy. So what I do is I just plug in negative infinity with an abusive notation, and I just let the question lead me. I just slowly simplify, and I just see what happens. So when I do that, I plug in negative infinity x, so it's 7 times e to the negative infinity minus 2 over 1 plus 8e to the negative infinity. So this looks a little bit nasty, so I'm going to try to simplify it. Keep going. I like to write my negative exponents, even if it's negative infinity, as a fraction to see what's going on here. So my next step is going to be 7 times 1 over e to the infinity. Hopefully you can see this. There's still a minus 2. And then 1 plus 8 times 1 over e to the infinity. That's that. And then what is e to the infinity? Well, you're just multiplying e a bunch of times. That's what e to the infinity sort of means in this abusive notation. So you're going to get 1 over infinity. What is 1 over infinity? If you watched our limits involving infinity video, what you do is 1 over infinity is going to be 0 because you have one thing, you're splitting it up into an infinite number of things. So all of this stuff is actually 0 because 1 over infinity is 0. Same thing with this term right here. 1 over infinity is 0. So our final answer here is just going to be minus 2. And that's that. This is technically same heavy, but you might not know what the biggest things are if you don't know how e to the x is compared to polynomials, or actually e to the negative x compares to polynomials. So it is actually same heavy, but some people might think the answer is 7/8, but that's not right. The answer is actually -2. So again, for these same heavy, top heavy, bottom heavy questions with exponentials, I just plug in the number and I just slowly make my way through the question, keeping in mind that a number divided by infinity, as the way we write it, what that means is you just have one thing divided by an infinite number of things, so that ends up tending towards 0, and you should be good to go. So just slowly work your way through these infinity questions when it's a little bit harder than just polynomial, and you can't apply heaviness rules. So last question of the day. Limit as x goes to 0 of this complicated guy right here. Well, this looks L'Hopitalable. Let's just see what happens. When you plug in 0, if you don't know, tangent of 0 is 0, because on the unit circle, that point is 1 comma 0. Tangent is y over x, so you have 0 over 1. Basically, tangent of 0 is 0. Then, because tangent of 0 is 0, that means inverse tangent of 0 is 0. So it looks like we do have L'Hopital's rule. Time to lope that tall. But again, please please be careful with the chain rule. Let's be careful with the chain rule when we do this question. So what we're going to do is we are going to take the derivative of this top thing. That's going to be secant squared of 3x, because that's the derivative of tangent, secant squared. But we're not done with the derivative of the numerator. We do need to multiply by 3. So we're going to write times 3. Because 3x is, the derivative of 3x is 3. That's the chain rule. Don't miss those little chain rules. Now for this derivative, if you don't know the derivative of inverse tangent, it's 1 over 1 plus x squared. So we have fractions within fractions, but I think we'll be okay. 1 over 1 plus, because 7x is the inside function, it's going to be 7x squared. Don't just write 7x squared without any parentheses, because technically this will be 49x squared. And then you do need to multiply by the derivative of the inside. Again, it's the chain rule. The chain rule is our friend. Let's not ignore it. The derivative of 7x is times 7. So let's see what we have here. This looks pretty complicated, but actually it simplifies pretty well. When you plug in 0 in the bottom, it'll be 0 squared, so this term goes away. 1 plus 0 is 1. 1 over 1 is 1. So it looks like in the denominator we'll just have 7. Then you might not know how to find secant of 0 or secant squared of 0 when you plug that in. But just keep in mind that secant is the reciprocal of cosine. Cosine of 0 is 1. So this term as well, even after you square it, because it's 1, is still 1. So our final answer looks like it's going to be 3/7. But most important is that when you're applying L'Hopital's rule, when you take the derivative of the top, derivative of the bottom, just remember the chain rule if it's necessary. So that really concludes our video. We did 9 practice questions ranging from difficulty easy to hard. We talked about our 3 limit ways, limits involving infinity. We talked about definition derivative. We loped that tall a few times. And so hopefully this provides you a comprehensive review of each of these 3 types. Again, if you need to, just go back to our previous videos, our Girls Teach Calculus videos, or the ones I make, to practice more of these in depth. If you just want to practice, for example, definition and derivative questions, if you just want to practice L'Hopital's rule questions. But we have another Girls Teach Calculus video in the description of this video, where one of my former students goes over more of these questions, more than 9, I believe, where she practices some same heavy questions. She practices some definition or derivative questions and some L'Hopital rule questions, where in all 3, she might be using the chain rule. So be on the lookout for that. Hopefully you found this useful. If you did, give us a like and subscribe. In our next videos, we're going to be talking about harder ways to take, or derivatives of more complex functions that will require implicit differentiation, that will do logarithmic differentiation. But hopefully this was useful. Again, limits are hard, so just keep practicing limits, and I believe that you'll be able to do it. But thanks again for watching, and I hope to see you next time. Thanks again.